To answer this question, we need only extrapolate from what we just did. We know, for example, that going from capacity 100 to 101 required us to create and fill 101 memory boxes. That was this picture here. To go from 101 to 102 is 102 memory boxes, and so forth. And so ultimately, everything boils down to what is the sum of 101 plus 102 plus ... plus 1,000. So this is a math problem you might not right now feel comfortable know how to solve, or might not feel comfortable knowing how to solve. And so one approach is to go to Wolfram Alpha, which is a handy tool, and we can just say equals this, and we'll add them all up, and we'll say around 500,000, which gives us our answer. Now we don't want to be totally dependent on Wolfram Alpha, so in this class later, we're going to use a number of different tricks. And so here, the trick that is best, the way that you could actually do it without consulting some external tool, would be to keep in mind that the sum of 1 plus 2 plus 3 plus ... up to n is equal to n times n plus 1 over 2. This is something you surely learned at some point. You might have forgotten it. There's a whole link here if you want to read about why that's true. And so we can say that the sum of the numbers 101 to 1,000 is going to be not that much bigger than this sum, because those first 100 numbers aren't very large. So this last little bit, we can approximate it by just doing 1,000 times 1,000 plus 1 divided by 2, which is around 500,000. So that's one way to do it. Okay, so let's compare side by side. This is what our S-list was capable of. Whenever you insert into an S-list, what we show on the y-axis, this is the total time to complete all of those inserts. So in other words, inserting 200,000 items in this theoretical plot took only 0.00002 seconds. Inserting 40,000 was 0.0004, and this is a purely theoretical number. This is not an actual experiment. However, if we ran an experiment, we would really expect to get a straight line. So this straight line indicates that the operations for the S-list are all constant time, because the integral of a constant is a line. By contrast, if we look at the A-list, which is much slower, and the focus of our attention right now, and thus we get a bigger font, what we see is that it's actually a parabola. So that inserting 20,000 items is not nearly as slow as 100,000 items. And in fact, inserting 100,000 items, if we do the exact same Wolfram Alpha type trick, we'll see it's around 5 billion new containers, new memory boxes. That's a lot. And since computers operate they do at the speed of around gigahertz, that is, they do about 1 billion things per second, it's no big surprise that inserting 100,000 items took seconds. So if you think 5 billion divided by 1 billion, it's around 5 seconds. My computer did a little better because it's a little faster than the gigahertz. Just a rough rule of thumb. And so this parabola actually tells us that as our list gets bigger, it takes longer and longer for the operations to complete. In other words, the time per operation is linear. And the integral of a line is, of course, a parabola. And this right here is unacceptable.